Okay, so in these two examples, we will be looking at the slightly more complex question in polygon. Okay, so not very complex, but it's just that you need to be able to read. Okay, so in example 10, okay, we are faced with a regular polygon. So you look at the alphabet A, B, C, D, E, F. So if you trace the alphabet, it should form out a regular hexagon, so which is a six-sided figure. So make sure you are able to trace out the alphabet to tell where is the hexagon. Okay, so the blue color part here is the hexagon, and because it's a regular one, it will be good that you do some indication. So I emphasize that you actually do an indication. How do you do an indication? You dash the length. So when you do such a dash indication, you are telling everybody that the length are the same. You are also telling yourself that it is all same size. Okay, so it's six-sided and it's all regular, all same length, which also means that the interior angle will be the same, the exterior angle will also be the same. Okay, and the next thing you need to understand will be this statement that some students cannot understand. So when we say BA are produced. So when we say something is produced, it's the same thing as something is lengthened. So we make it longer. So when we say BA is produced, okay, so how do we, so from B, that means from B to A. So from B to A, you make it longer. That is the meaning of BA produce. BA produce means from B, you go to A, then you make it longer. So it's the same thing here, EF. So EF is produced. So when EF is produced means from E, you go to F. So from E, you go to F, then you will make it longer. So the question is saying that BA produce and EF produce, they produce until they reach a point T. So B to A, then you make it longer. E to F, you make it longer until both of them meet at T. So that's what the question is trying to say. Okay, so you got to understand the question first before you can do any answering. So make sure you are able to understand the produce thing. Okay, and make sure you are able to see the hexagon. Okay, so after you digest where is the hexagon and what do we mean by the length is produced until T. Okay, the question is asking you for ATF. So the question is asking for ATF, which is part of a triangle. So the question is asking for ATF. So how will you approach it, right? Common sense will tell you that this is a six-sided figure. So no matter what, you can find all the interior angle first. So no matter what, you find all the interior angle first. So you find the total interior angle for the six-sided figure. You will get a 720. And then this one is regular. So if you divide by 6, it will give you each of the angle here. So there's a lot of 120 around. So that is the property of a regular polygon. So with all the 120, okay, you can use angle on a straight line. So you can use angle on a straight line to find TAF. So TAF is actually the same as TFA. So it will be the same as 180 minus 120. And what's the reasoning? It is angles on straight line. It will be angle on a straight line. So this two will be 60 degrees. So from here, I can actually find what the question wants. So the question is asking for angle ATF. So I can do an angle sum of triangle. So I will do an angle sum of triangle. So that will be a 60 degree. Then eventually the last part, what type of triangle is ATF? So you observe the triangle here. All the angles are the same. So the type of triangle where we describe all the angles are the same will be equilateral triangle. So triangle ATF is an equilateral triangle. Okay, so that is the thing that you will need to process the information, indicate for regular polygons, and you apply. In the next question, it's the same thing. In the next question, we also have a regular octagon and a regular heptagon. So octagon will be 8-sided and heptagon will be 7-sided, and both are regular. So as long as it's regular, you need to indicate. So which one is the heptagon? You can count the number of sides. So this is the heptagon. This is the 7 sides. And then the other one, also regular, but this one is 8-sided. So from here, we are supposed to find the value of x. So if you look carefully, I can find each of the interior angle here. I can find the interior angle in the heptagon. I can also find the interior angle in the octagon. And then I can do a angle at the point to find x. So that will be the plan. So 8-sided figure and being regular, you know how to find. 7-sided figure as well. So you do for n equal to 7, find the total interior angle first. And then you find each of them. So it's not a very nice number. So you can correct to 1 decimal place. So this is 128.6. So each of the blue color interior angle is 128.6. So here is 128.6. And then I'm going to find the red color one. So for the octagon, so same thing, you find the total interior angle. And then to find each of the interior angle, you divide by 8. So all these are 135. So eventually your aim is to find x. So now if you take a careful look, if you want to find x, you will be using angle at a point. So if I want to find x, it will be 360 subtracting 128.6, subtracting 150. So the property is angles at a point. So with the property of angles at a point, it helps you to do the subtraction. So that you will get x to be 96.4. Okay, so in some question, right, in some other exam question, sometimes they actually draw you a line. Sometimes they actually draw you a line. They connect these 2 points. And they actually ask you for this angle. So if you're asked for this angle, you need to realize that this is an isosceles triangle. So you need to realize that that is an isosceles triangle. And if you do not do an indication for the regular octagon or the regular heptagon, that means you don't do the dash, dash, dash. So you don't dash it to show same length. You actually cannot realize that that is an isosceles triangle. So that's one of the more tricky questions sometimes. Okay. So with these 2 examples, basically you and the previous practice that you have for all the formulas in this topic, you should be able to play around with all the types of questions relating to polygon.